Hello, Chemistry 12. This is Mr. Chan, and today's lesson is basically a quick review of Chemistry 11 material, and hopefully to help you sort of remember things that you should have learned from your teacher last year. And when we talk about solutions, last year there should have been two solutions that your teacher should have touched upon. One of them is called ionic or salt solutions. Now, what is an ionic solution? Is an ionic compound or salt that is dissolved in water. And what happens is the salt or the ionic compounds breaks down into its component ions called dissociation and is represented by a dissociation equation. So the first thing I wanted to touch upon is what is an ionic compound? Now, remember back from Chemistry 11, ionic compound is basically a metal, non-metal molecule. So why do we call NaCl salt? Is because sodium is a metal and chlorine is a non-metal. Now, so that's why we call it ionic compound or a salt. Now, one of the things that you should be aware of is this. The ions in solution is called electrolytes. And because there are ions are in the solution can conduct electricity. So this gives you an example of, when you drink Gatorade, why do they say, oh, replenishes your electrolytes? So basically what it is replenishing the ions that you lose via sweating. So in the example that I have here, let's say we have sodium chloride. You folks know that sodium chloride is an ionic salt. Okay, so what happens here is in this particular case, this would be a salt, and this would be a solid. How do I know that? Because of this little subscript here, what you should have learned back in grade 11. What happens is that in water, it dissolves into ions in solution. Now, how do I know that it is solution? Is because of the phase symbol AQ. This is why we have it as solution. And notice I have my ions of +1 and -1. That's where I have my ions. Now, this entire equation, this is called, if I'm going to move this over, this is called the dissociation equation. Okay, and hopefully this, you remember this from Chemistry 11. Now, one thing I would like to highlight right here is make sure you know the difference between a dissociation equation and a decomposition reaction. They look the same, but they are actually quite different. For a dissociation equation, what you get here is the resulting thing is you get ions in solution. But what happens with decomposition is it looks the same, but the result is you get neutral elements. So that's one thing I would like for you to be aware of, is make sure you know that dissociation and decomposition are two totally different things. Dissociation, you get ions in solution. Decomposition, you get neutral elements. Now, the other type of solution that you should be familiar with is called covalent or molecular solutions. In this case, the covalent or molecular solutions is composed of covalent compound dissolved in water. There is no dissociation, okay? And as a result, cannot conduct electricity. Another name for that is called a non-electrolyte. Now, An example here would be what I have written down here. So the C6H12O6, this would be like sugar. Again, this would be like the solid. So this is the stuff that like in sugar cubes. And what you have here, when you dissolve it in water, what you get here is you get sugar solution. Now, how do I know one is a solution, one is a solid? Is by looking at the phase symbols. This would be solid, and here AQ would be sugar solution. We recall AQ means that it is able to dissolve in water. Now, if I zoom out here, you notice the difference between the two equations. One provides ions in solution. That's what happens with the sodium chloride, breaking apart into sodium +1 and chlorine -1. And what you have in the second example I gave you, notice the entire molecule stays together. The carbon, hydrogen, and oxygen stay together. You do not break it apart. Now, if I wanted to show you the difference between the two, so let me see if I can screen share here. Let's do screen share. So let's take a look for this example. Let's say in this example here, I have water that is dissolving into sodium chloride. Now, what happens is when it dissolves in water, the water molecules surround the sodium chloride, and what happens is that it breaks apart into its component ions of sodium and chlorine. So what you have is you have ions result in solution. Okay. Now, if I were to do sugar, so let me see if I can cancel this. Let's do a new share. Let's look at this one here. Okay. And let's say I do this one. Where I have sugar, what you have is, in this case, you have water molecules that are surrounding the sugar molecule. But in this case, notice what happens with the carbon, hydrogen, and oxygen molecules. They don't actually break apart. What happens is the carbon, hydrogen, and oxygen stay together, and this is why you have no ions in solution. So this particular substance cannot conduct electricity. Okay, so this is the difference between an ionic and a molecular solution. So what I'm going to do is I'm going to pull this out. Okay, and I'm going to share screen, and I'm going to go to, where is my, there we go. Okay. Now share. Okay, so that is the key difference between a dissociation equation and a molecular solution. Okay, so a difference between ionic solution and a molecular solution. Now, when we talk about solids dissolving, there is one term that I would like you to be aware of, is the term solubility. Okay, and what solubility is the maximum amount of substance that will dissolve in a specific volume of solution, or the amount to form a saturated solution, or the amount needed for the solution to reach equilibrium, okay, with the solid. Now, the key thing I would like you to be aware of is this. The word saturated solution and equilibrium mean the same thing. So if I said a solution has reached equilibrium or a solution is saturated, then that is basically talking about the same thing. Now, when we talk about solubility, we either use grams per liter or moles per liter. Okay, so both units is something per liter, but one is grams and the other is moles. And when we use the word moles, that's called molar solubility. Now, when we talk about solubility, one thing for you to be aware of for chemistry 12 is when a substance is soluble in solution, what that means is that greater than 0.1 mole or greater than 0.1 mole here of a solid can be dissolved per liter of solution. Okay, now one thing is this, I don't know if you were exposed to this back in chemistry 11, but if you looked at your solubility table, you will notice the word here, the term soluble means greater than 0.1 moles per liter of solution can dissolve. Okay, so when you see the word soluble, it means that you can dissolve more than 0.1 moles per liter of solution. Okay, all right. Now, a couple of things that you should remember from chemistry 11. Number one is concentration. When we talk about concentration, concentration is the actual amount of substance that dissolves in 1 liter of solution, and the units is molarity. Okay, now, so I don't know if you folks remember this from chemistry 11, but you could use a little triangle where you have molarity, and it'll give you the formula of moles and liters. So you could think of it like this. In here, these are dividing, and here is multiplying. So if I wanted moles, I can cross out the moles. What we would do is molarity times liters. Now, conversely, if I can erase this, if I wanted molarities, I cross that out. And what that does is that it's moles divided by liters. Okay, so let me give you an example here. So let's say, for example, if 5 grams of aluminum nitrate is dissolved in 0.5 liters, calculate the concentration of aluminum nitrate and the concentration of ions. Now, so what you should remember from chemistry 11, so the first step is you want to find the number of moles. So what we have is we have 5.0 grams of aluminum nitrate, NO3 brackets 3, times 1 mole over the molar mass of aluminum nitrate. I think, was it aluminum, if we look at the periodic table, is 27. Oops, let me see here. So nitrogen is 14 times 3, and oxygen is 16 times 9, and 27. So this would be 213.0 grams. And if we take 5 divided by 213, that would give me an answer of 0.0235 moles. Okay. Step 2 is you want to find the concentration of aluminum nitrate. So what you have is 0.0235 moles divided by 0.50 liters. Okay. And that would give us 0.5. And that would give me 0.0469 molarity. Now, that's just to solve for A. Now, when they want the concentration of ions, you know that aluminum nitrate is a ionic solid. So we write the dissociation equation. So aluminum nitrate, brackets 3, breaks apart to aluminum plus 3 and 3 nitrates. Okay. So this gives us the mole ratio. So if this is 0.0469, 0.0469. This would be 0.0469. And the nitrate would be 0.141 molarity. Okay, so if we wanted the concentrations here. Again, why is it 0.141? Because here you want to recall this follows mole ratio. Okay, so that is something for you folks to be aware of. All right, now what I'm going to do is I'm going to stop it here, just really quick, because giving you folks some time to catch up with the material. And then the next video, I'm going to be going over the words dilutions, as well as precipitation reactions and qualitative analysis. All right, thank you very much. Have a great day. Bye-bye.